Okay, so this is an intro to hypothesis testing. So if you remember, we used confidence intervals to estimate the unknown population parameter. We assumed that that population parameter would be in between the two numbers that we had at our final interval. And now we're going to look at a more formal method for testing. So whether a given value is a reasonable value of a population parameter. So in order to do this, we need a hypothesized value of the parameter first. So we're going to be computing the probability that a population with the specified parameter would produce a sample statistic as extreme or more extreme to the one we observed in our sample. So this is known as the p-value, which is used to estimate statistical significance. We're going to talk about it more a little bit later, but statistical significance just really says that the differences observed in one sample were due to actual differences in the population, and this data pretty much just saying that our data is valid and important and significant in this case. So the first step in hypothesis testing is writing hypotheses. So each test has a null hypothesis and an alternative hypothesis. You'll see the null hypothesis indicated as H with a sub-zero under it, and then the alternative hypothesis will be written as H sub A. And the difference between the two is that the null hypothesis states that there's not a difference in the populations, while the alternative hypothesis states that there is a difference in the population. So there are three things to know when you're writing your hypotheses. So first, and very important, the parameter we are testing is going to be used when writing the hypotheses. So you know that you have two different symbols for each parameter and statistic. So for a proportion, your parameter would be p, and your sample statistic would be p hat. And for a mean, you use mu for a parameter, and you use x bar for your statistic. For hypothesis testing, we always speak in terms of the parameter. So for proportion, we're going to use p, and for mean, we're going to be using mu. So the next important thing is the direction of the test. So whether it's non-directional, right-tailed, or left-tailed, you'll be seeing left-tailed when you're speaking in terms of something that is less than another thing, or right-tailed is greater than. And third, the value of the hypothesized parameter. That's just the number that goes into the hypothesized statements. So you can say p is equal to 0.50. In that case, 0.50 would be the value of your hypothesized parameter. So just here's some examples of writing your hypotheses. So here we're just going to walk through it, identifying the parameter, the direction, the value of the parameter, and whether it's null or alternative. So here is an example of a null hypothesis because we have an equal sign here. And it is a single mean because we're using mu. It's non-directional because we're not using greater or less than, which would be indicated by the greater or less than symbols. And 0.50 is our value of the parameter, since that is the hypothesized number. And again, it's null because we have that equal sign there that states that there is no change in the data. So next, p is less than 50 is a single proportion because we have p. It's left-tailed because we're doing a less than test. 0.50 again is the value of our parameter, and this is an alternative hypothesis. All right, so you have two more. So this next one is a difference in proportions because it says p1 is equal to p2, so that means that there is no difference between the two numbers. It's non-directional because, again, there's an equal sign. The value of our parameter is p1 minus p2 equals 0 because if p1 and p2 are the same number, their difference would be 0. And again, this is null because of that equal sign there. So the last one, single proportion here because we're using p. This is a right-tailed test because we're using a greater than sign. 0.31 is our hypothesized parameter, and this is an alternative test since we're using a right-tailed test. Okay, so here's an example of actually writing your hypotheses when you're given a question. So, is the average IQ score of all World Campus Stat 200 students higher than the national average of 100? So first we're going to start with we need to find a null hypothesis and an alternative hypothesis. So first we're going to identify what population parameter we need to use. So the key word here is the third word, is the average IQ score. So average here indicates that we're going to be looking for a mean, so we're going to be using mu. Starting on top with our null hypothesis, we're always going to use equal to, because that indicates that there's no change in the data. And then we're going to be using 100 because that's the data we're given here. We're asking if the World Campus Stat 200 students is different than the national average, higher than the national average, which is what we're going to be sticking to in our null hypothesis. So 100 will be used there. And this is going to be a right-tailed test since we're using the word higher. So we're going to be using a greater than sign for the alternative hypothesis. Okay, so constructing a sampling distribution can be used to make inferences about the population. So we construct this randomization distribution given that the null hypothesis is true. So we can use this distribution to find our p-value, and then once we find our p-value, we can decide whether we want to reject or fail to reject the null hypothesis. So this is really our decision here. So if we go back to the last slide, we have our hypotheses. We asked, is the average IQ score of all World Campus Stat 200 students higher than the national average of 100? So based on that question and what our data looks like, we're going to have to come to a final decision. So our null hypothesis states that if our null hypothesis is what we decide on, then we are saying that the average IQ score of all World Campus Stat 200 students is not higher than the national average of 100. But if we go with the alternative hypothesis, we're saying that the average score is higher than the national average of 100. So when we make that decision, we have to write it out in specific terms. And there's specific ways that we can make that decision. So you decide if you reject or fail to reject the null hypothesis. So those are the two decisions. So you either say we reject the null hypothesis or we fail to reject the null hypothesis. When we're making a decision, we don't speak in terms of the alternative hypothesis. I'm not exactly sure why, but that's just how it is. We never accept it, and we either reject or fail to reject it. So don't accept and don't conclude in terms of the alternative hypothesis. And then once you get that, you're going to state a real world conclusion, just putting that decision in context of our example before as the Stat 200 IQ scores. So p-values, as I mentioned before, is how likely our sample proportion is given that our null hypothesis is true. So we compare the p-value to alpha. Alpha in this course will typically be 0.05 unless otherwise stated, but if you're asked to compare to alpha or to reject or fail to reject the p-value and you're not sure what alpha is, always go with 0.05 unless it's otherwise stated in the problem. So two decisions here. If the p-value is greater than alpha, that means if the p-value is greater than 0.05, then we would fail to reject the null hypothesis. So when we fail to reject the null hypothesis, we're saying that there's no sufficient evidence to say that there is something actually going on. On the other hand, if the p-value is less than alpha, which is what we want for our statistics, because it says that we have statistical significance, then we reject the null hypothesis. So when we reject the null hypothesis, we're saying that there is a difference in the population. So it's saying that this data is statistically significant. And again, a p-value less than alpha is statistically significant. Okay, so we went through that pretty quickly. Now we're going to go over like 4 review questions just to see if you guys got it. So the first one, do the majority of all World Campus Stat 200 students own a dog? What is the correct null hypothesis for this research question? So take a couple moments, figure out your answer, and just write it in the chat box, and we'll go over it soon. All right, so our answer here is B. So we're looking for the correct null hypothesis for this research question. So since it says null hypothesis, we can automatically eliminate answers C and D because those are not in the format of a null hypothesis, while A and B are, since they have the equal signs there. And then since we're looking for, it says majority, so that would be a proportion. Just the key thing to remember here is that we're using parameter. So that would eliminate p hat, since we always want to speak in terms of the parameter. All right, so the p-value for a test statistic is 0.10. Is this statistically significant, yes or no? All right, so this question should be pretty quick. The answer here is no. So to compare p-value to see if it's statistically significant or not, we compare our p-value to alpha. And here, since we're not given a specified alpha, we can assume that our alpha is 0.05. So the rule of thumb is if our p-value is less than 0.05 or our alpha, then it is statistically significant. And since 0.10 is greater than 0.05, this is not statistically significant. So good job there. All right, we use StatKey to construct a sampling distribution based on a research question. We get a p-value of 0.04. What is our first conclusion in terms of hypotheses? All right, so A is our answer here. Great job. So right off the bat, we can eliminate B and D because we don't want to conclude in terms of the alternative hypothesis. And really just deciding between A and C here is determining if our p-value is statistically significant. And since it is, we should reject the null hypothesis. So good job there. All right, this is our last question. Is the mean height of in the population of all World Campus Stat 200 students different from 65 inches? I wrote down the hypotheses for you there, and after constructing a sampling distribution, we get a p-value of 0.0. Which of the following is true? So here, this is a multiple answer one. Awesome. So our answers here are B and C. So it's a common misconception that if we get a p-value of 0, this doesn't mean anything for our data, but p-value of 0 is really the best p-value we can get because it shows that our data is extremely significant. So we definitely should reject the null hypothesis here since it's less than 0.05. And then C and D here are just concluding statements that put it, that take the decision one step further and put it in terms of the question. So since we reject our null hypothesis and we say that our data is statistically significant, there is evidence that the mean height in the population of STAT 200 students is different from 65 inches, since the data, that's what the data says it is. So